Kia ora. Here are two more questions from the mixed up worksheet. These are both excellent ones. So the first question is one where we're told that both this and this have a common factor of x minus p. And then we have to prove that this is true and everything is real in it. So the easiest way to do this is to use the factor theorem. And we're going to set up the first quadratic as p of x squared plus bx plus c. And I'm going to call the second one, we'll just call it q of x. And we know that the factor theorem tells us that because x minus p is a factor, by the factor theorem, we can write two equations. We know that p of p must equal 0, so that's p squared plus b of p plus c equals 0. And we know that q of p, so again substituting p into here, must give me 0. Well, that's what it means for something to be a root. All I have to do now is to equate those two things. You're doing a proof question, so don't skip any steps. Right, simplifying here, look at where we're trying to get to. We're trying to get to making p the subject, and we're just about finished. So we have bp minus dp is equal to e minus c. Factorising here, we get p into b minus d is equal to e minus c. So we get p is equal to e minus c over, b minus d as required. So that's that one done. So hopefully you didn't find that one too bad. Probably other ways to do that, brain not really working right now, and the factor theorem to me is just so obvious with that question. So feel free to leave me a comment if you think that there's a better way to make this video, and I will remake it for you. Right, now next one, prove that the roots of this are always real for all values of c. So that should immediately suggest to you that we're going to be looking at the discriminant. Roots are real when the discriminant is 0 or greater. So for real roots, we need b squared minus 4ac greater than or equal to 0. So we're just substituting in, and then we have to somehow show that it will always be positive. So b squared minus 4ac is equal to 2c plus 1 squared minus 4 times 3 times negative c plus 3. Right, that's my c there. And expanding and cleaning up, we get 4c squared plus 4c plus 1 plus 12 into c plus 3, giving us 4c squared plus 16c plus 37. Now, if we want to show that something's positive, the best way to do it is to show that we've got a square, right? Because squares can't be lower than 0. So we're going to complete the square on the first bit, and then hopefully the leftover bit is never going to take us into negative numbers. And that's what happens here. So I'm just going to take out the factor of the 4. So we get 4c squared plus 4c plus 37. And that's easier than doing a 2c completing the square. So fully factorise that bit before you start. That gives us 4 into c plus 2 all squared. So that matches up this, but I have now added in an extra 16, so I'll take it out, giving me 4 times c plus 2 squared plus 21. And that's greater than or equal to 0 plus 21, which is greater than or equal to 0. So we have shown that b squared minus 4ac is greater than or equal to 0, and roots are always real. Okay, so it doesn't matter what value of c we've got, we will end up with a positive number. So not even a 0, a strictly positive number. Right, that's all for that question. I've got a couple more to do, and then I'm taking Friday afternoon requests, which is pretty tragic, but send in any last questions for the week. Thanks.